All right, guys, let's talk about homework. Okay, guys, let's focus. All right. So, anyhow, homework 20. And Greg, I know you don't have your homework, but if you want to take notes on the homework, you can. Um, Actually, let me get you a copy of the homework. Actually, I don't have it. No, bad. All right. All right. Let's keep it. Actually, hold on. I have it. Here we go. Okay, girls. We gotta do work. Okay. So for 8105, just remember if you have a hexagon, you have 6 triangles you can make. Each of the triangles will be equilateral because the way a hexagon looks is like this, right? And what's the measure of this angle right there? Well, that's 60, but when you cut in half, it becomes 30. And then you create this, right? Then you create 30, 60, 90 afterwards. And remember, if the side, the side length is 4, you cut that in half, that's 2. And you use your ratios for 30, 60, 90, which we'll provide to you. We always provide you that. Or you use trig, it's up to you. Once you have the base and height, you get the area of that triangle, double it to get this triangle right here, and then multiply by 6 to get the area of the hexagon. So hope you guys are okay at that one. For 106, you have a trapezoid, and you have the dimensions there. You can break it down in that manner. If you break it down in that manner, you should, and you have the heights 4. That helps us find this little sliver, which is 3, right? I mean, this has to be 2, which makes this kind of a funky number. That's fine. And you get the perimeter area after that. So, and this says here, find the area and perimeter of trapezoid is similar, but reduced by 1/3. Great. Reduce the perimeter by 1/3. But the area you don't reduce by 1/3. How do you reduce the area? Remember, what's the scale? If the scale factor is 1/3, what's the scale factor for what's the ratio of the areas? What do you do to the scale factor to get 1/9? Right, you have to square it. Correct. So the area scale factor becomes 1/9, and so the new area is 42/9. So just so we're aware. For 107, we got to do some trig here, I think. No, not at all. Yes, no, we do. Never mind. If you have 18 degrees as a central, sorry, the extra angle, that means you have 20 sides. You have 20 sides. You can figure out all the rest, right? It's not that hard. Work it out. You should get the answer there. We've done this many times. For 108, just old school stuff, it looks like. The diagram at the right. Oh, yeah, there we go. One down below. Yes, parallel lines. You should know what's going on there. D and K actually equal each other. B and N, all add to 180. They have 180. For 109, that's just more. We're going to move into 3-dimensional geometry later in the year. So just kind of get you thinking about that. I think that's what's going on there for that one. Yeah, that's what it looks like that's happening there. For 110, more trig. For 111, you guys should know that. They do bisect for a square. They do bisect for rectangle. They do bisect for rhombus. Trapezoid, they may not. Only if it's isosceles. They bisect. And again, 110 just using basic trig skills. 116. Okay, moving to area of circles and perimeter. Sorry, and circumference. We talked about this already. You guys should be fine there. And lastly, we're doing matching for 119. No, that's not the last one. Hopefully, you guys are okay with the matching. Hexagon, that would totally make sense. Interior angle is 120. Decagon, you got that. Equilateral triangle, you got that. Square, you got that. So then finally for 120, f of 1 is -3. F of 0 is -4. Where y is 4, you can just look at it. It's actually kind of hard to tell. Yeah, so here's what I would do. Actually, yeah, how would you do C from looks, right? Zoe, Reagan, please. I'm trying to. Yeah, okay, thanks. Okay, before I do C, let's talk about A. A is pretty easy, right? You get -3. F of 0 is easy, -4. Where y is 0, hope that's easy, -2 and 2. Here's where it gets tricky. How do you do part C? What I would do is try to model the equation, meaning try to come up with an equation for the graph. If you think about it, y equals x squared looks like this. Hope you guys talked about this in middle school. I hope you guys did graphing. I don't know. And notice it shifts 4 down. You'll talk often about shifts in algebra 2, but we kind of did that a little bit. We did do translations. You have to take away 4. That's going to be the equation for this graph. Plus, also, if it's crossing at -2 and 2, your factors are this. So what I'm doing is I'm taking the graphical interpretation of this function and relating it to its algebraic. I'm creating an algebraic equation, right? So that's going to be the equations, x squared minus 4. Now, if y is 4, how would I solve for x? Well, I just described that because it shifted 4 down. So it's a translation, but also the fact that it's crossing the x-axis at 2 and -2, making x minus 2 and x plus 2 the factors. Those are the 2 reasons why. It's x. If you FOIL that, you get x squared minus 4. So we're cool with that. Good. Then what you want to do is set the equation equal to 4 and solve for x. And you get this. And then you get plus or minus √8. So in the instructions, it looks like they did the vertex form, which is a translation, but we haven't really talked about vertex form in this class. So that's why I don't want to, that's more of an algebra 2 thing. I think just take a look at y equals x squared, which you guys should know how that looks. That's a parabola, but it shifted 4 units down. That's why it's a -4. And then solve it by setting equal to 4 and solve for x. You get that. And then you can rationalize it or simplify it by making it plus or minus 2√2. Positive 4?
Yeah, it says x if f of x equals 4, but you never use a positive 4, you only use a negative.
No, we did use a no. No, that's over here. We used the positive 4. We said equal to 4. This was the transformation. That was shifting 4 down. That's a correct. No, this is shift 4 down.
Yeah, I was just like
Right.
positive. How do you use that in the equation? So you can just like sub it in the spot.
Correct, because that's what they're asking you to do. They want you to do that
Yeah.
at the end, right? It just happened that the shift and what it equaled happened to be the same thing. That's a coincidence. Yeah. Solving. You will see it in algebra 2 a lot. Don't worry for now. I think this is more just trying to get you thinking about algebra 2. Yeah, I taught algebra 2 for many years. You'll see this in the fall. So what was that?
Why at 1
Oh, you just look at where x is 1. What's the y value? -3. Yeah.
But when the x value is 1.
Yeah.
But how do you know like f of 1 is supposed to equal x?
Okay, function notation. And that's okay. We probably haven't spent enough time about this. When you have function notation, whatever's inside the parentheses is x. And whatever it equals is your y coordinate. So f of x is y. Whatever's inside the parentheses is x. So when you see f of 1, here's how you interpret f of 1. F of 1 is like saying, there's a text box. So you could do 2 things. You can say y equals x squared minus 4. Here, let me rephrase this. If, then find what y equals when x equals 1. Or you say this. F of x equals x squared minus 4. Find f of 1. Those are the exact same thing, but we have function notation because that's much shorter than writing the top statement.
So it's basically saying f of, so if it was like f of 3, for example, then
Plug in 3.
you know that the x coordinate is 3 because it's inside the parentheses.
Correct.
What it equals is the y coordinate.
Correct. I'll just say this, we're lazy as mathematicians, so we want shorthand notation. That second statement is much shorter than the top statement. It's the same thing. It's just a language. It's just interpreting. And that's what you're asking. How do you interpret? And that's fair because we haven't done enough work like this. So yeah. So, all right. Homework review is over. Let's now move on to the notes. Okay. So I had this very ambitious plan because we have 75-minute periods to get everything all done today and we could just eat pie on Thursday, but I don't know if we can do that. Plus, it might be a little overwhelming. So I'm gonna try to go as far as we can today, but it's okay if we don't finish the entire notes, but we will finish the notes on Thursday, unless it's Kanji Thursday morning. I don't know. Okay. Um, but let's go to where we left off in the notes. I love Kanji. Kanji I love. That's okay. It's fine. Okay. Let me rephrase. Okay, so probably the coolest kanji we ever had was in 2012. It was like I was my eighth or seventh year here. I remember it so well because we actually had three colleagues retiring, and they flew in their families, and everyone got all teary eyed and like. And these are like really close friends. Two of them have passed away since then, but um. So the way we do kanji, we want as a surprise, right? So our principal at the time said we're going to celebrate the retirement of these three colleagues, but it was also kanji too at the same time. So he called, but these three colleagues didn't know that we're doing a special celebration for them. So we call them up, and then he's surprised by bringing their families. They're hiding behind the stage. Their families come out, like someone flew in from like all over the country. On top, I guess you guys are not paying attention. All right, okay, I'll no. So I'm always asking why I prefer kanji over Spirit Week. Kanji is more sentimental, and I was giving a sentimental story about it. That's all. And we were celebrating the time with three colleagues, and so they flew in their families, and then we had kanji, and I like kanji for that reason because there's more of a sentimental feeling to it. So Spirit Week, Spirit Week, we've had some issues over the years. So actually, no, my first year here, which my first kanji was in 08, that class had two kanjis. They had a class when they were freshmen. It says they had a kanji when they were freshmen, and they had a second kanji as seniors. So it can happen. It can. It can. Maybe. But also, what was I gonna say? Other schools do. You see, other Sacred Heart schools they do kanji every year. Other Sacred Heart schools they do kanji every year. Yeah, like the small. I know what's wrong with us. I don't know.
Probably like that though. Like, is it like a meat like you trust and like
We do. We go all out. I think compared to other schools, we go all out. I mean, we have. Well, we also have a lot of money. Let's just be honest. We're probably one of the more.
1%?
Well, we're also in the wealthiest zip code in the country, right? I mean, compared to.
So
And I've seen those schools. I mean, like Seattle's nice. The school in Montreal, New York is nice, but I don't know. We do pretty well here. All right, let's get going, guys. So 8101. Okay, hey, you got girls, please. Several times. Let's get to work. Okay, 8101. All right, so read the definitions of circumference and area in the math notes box for this lesson. We know the formulas. I'll write the formulas up for you guys. So area, we know it's pi r squared, right? Circumference is 2 pi r. So when we ask to find the exact area, that means no decimals, all right? So it means the answer has pi in it. This is page 32. No problem. So the answer has pi in it. So if you're asked to find the exact area of a circle with a radius of 10, I'm just doing pi times 10 squared, right? And what's 10 squared? Good. So you have 100 pi. And don't forget, well, yeah, there's no true units here. So I'll say unit squared. Units raised to the second power. Like here, good. No, not at all. So we leave it alone. We don't touch it because you want exact. Now, because if you did, if you multiply that, that's actually not going to be exact anymore. It's going to be an approximation. Oh, it's up to you. It's your call. Yeah, it's up to you. Circumference. That's 2 pi r, or you do pi d. Because d is already twice r. So the 2 is already taken into consideration if you do pi d. So it's up to you. You could take half the diameter and use 2 pi r, or just plug in d straight up. Because I asked for the circumference, I'm just going to say 7 pi. Again, if you want to divide it, go for it, but you're going to double it anyway. So you're kind of spinning your wheels, right? So does A and B make sense? Very straightforward, right? Just plug and chug. No issues there. Cool. Now, how about area of a circle is 121 pi? What is its diameter? So you're working backwards. 121 pi equals pi r squared. What happens to the r's? Good. Sorry, what happens to the pi's? I meant to say. The pi's cancel out. So r squared equals 121. I got you. Good. These are stubborn. I actually don't like these boards sometimes. Yeah, when I move the desk around, they always fall down. Anyway, what's r gonna equal? Good. And then what's the diameter gonna equal? Because you got to double it up, right? Correct. So you have 22 units. And then another working backwards situation. Let's say we have 20 pi as a circumference equals 2 pi r. So you guys see how those setups are working? Does that make sense? I'm just using these formulas, right? But instead of plugging for r, I'm plugging for c. Or instead of plugging for r for the area part, I'm plugging for a for part c. And solve for r. What's r in this case? Good. Awesome. But you're not out of the woods yet. Yes. Then you have to area equals. And you're going to write units raised to the second power. And that goes right there. So just review from last week, right? Nothing too crazy. And speaking of woods, that was not really a pun, but just 100 pi unit squared. 100 pi unit squared. Yeah, exactly. Well, because now we're talking about the woods for 812. Guess we're not out of the woods yet.
Oh.
Yeah, okay. I didn't mean that. Okay. That was good, yeah. Giant sequoia trees in California. Famous for immense size and old age. Some of the trees are more than 25 years old. Tourists and naturalists often visit to admire their size and beauty. Some you could actually drive a car through. Is one, yeah, very famous where you can do that. Anyhow, so one of these trees, the General Sherman tree in Sequoia National Park, is the largest living tree on Earth. Pretty cool. The tree is so gigantic, in fact, that the base has a circumference of 102.6 feet. Assuming the base of the tree is circular, which is a rough assumption, but it's okay. How wide is the base of the tree? That is, what is its diameter? Here you can round to the tenths place. And how's the diameter compare to the length and width of your classroom? Well, I didn't bring any measuring tape, but I think we can guess what it's going to be. Anyhow, so yeah, how do I find the diameter? What are you told about the circumference? 102.6 equals 2 pi r, or you can use pi d. It's up to you. Personally, I'd probably do pi d because they're asking for the diameter. So 102.6 over pi equals the diameter. Now, in this case, we have to use a calculator. I can't do that in my head. Do you want to take a guess as to what that potentially could be?
33 roughly.
Yeah.
34
Yeah.
actually.
Yeah, sounds all right. So 102.6 divided by pi, 32.66 we'll say. Oh, tenths place. We'll do 32.7. Yeah. 32.7 feet. All right. The width of this classroom, I'm trying to guess. It's probably about 30 feet. So they're roughly equal. So yeah, that's kind of crazy. a tree like this wide, that'd be pretty nuts, right? So, anyhow, so they're roughly equal. Yeah, kind of like north near like Eureka, that area, or Shasta. All right, we're good. All right, let's keep moving. All right, so 8103. All right, so now let's look at this one here. Just more stuff on this. Yeah, this is where it's going to get a little dicey a little bit because we're going to start talking about sectors, but this falls totally in line with Pi Day because we are going to talk about uh, portions of a circle. And I'm going to do a little bit 833. Just kind of get set up for Thursday. So anyhow, to celebrate their victory, the girls' ice hockey team went out for pizza. The goalie had quite the appetite. She ate half of the pizza that 20 inches. What exact area did she eat? What was the length of the crust that she ate? Oh, this is a good one. I like this one. Okay. Okay. One thing I always advise you guys to do, always draw. Always, 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 always draw. Um, especially for the sophomores who you're doing SATs next year. You'll see these kind of questions. I strongly recommend you draw. Okay. So she ate half the pizza. It's crazy. Okay. So first off, what's the diameter of the pizza? So what's the radius? Good. Okay. And then let's shade the part that she ate. Okay, she ate all this, right? Okay. So let's get an eraser here. Let's redraw the crust for the top. Okay, she ate that. That's what she ate. So here's the deal. Let's find the area of what she ate, and let's find the length of the crust. So the length of the crust is going to be perimeter, or half circumference.
Wait, can we just find the area and then divide by two?
Correct. That's exactly what we're going to do. So what you're going to do is it's going to be the area. Does that make sense? Why I'm doing area divided by two? Yeah. So the area is going to be pi times 10 squared divided by 2, which will be 50 pi. And since that's for exact, there'll be 50 pi square inches. Okay, so she ate that much pizza. I know, sounds like a lot. Well, usually we measure food in calories or whatever, but fine.
Wrong to say I parentheses 5 squared.
You don't want to do 5 squared. No. Oh, okay, great. Actually, I'm glad you brought this up, Connor. Okay, so if you were to do that, here's the deal. Very, very important. PEMDAS, guys. Please excuse my dear Aunt Sally. The first thing you look at is parentheses, just a plain old 10. The next step is the E, exponent. So you got to take out exponent before you divide. You cannot divide before exponent doing the squaring. If you divide before, you will get a wrong answer. So be mindful about that. Square first, then divide. So the answer is 50 pi square inches. So it's just the area divided by 2. Now crust. If I think about it, we know how pizza works, right? Is the crust the inside the pizza or the outside the pizza? Outside, right? Does that count as the crust? What counts as the crust? That, exactly. So that's what they're asking.
So just half the circle.
Half circumference, exactly. Right. We're not gonna go that. Well, if you want to talk about thickness, like if you're talking about deep style, Now we're getting to volume, but we're not there yet. But that can impact also how much you can eat, right? Because a thick, a thick pizza, it's a little hard to eat that. Yep. So anyhow, you're gonna do 2 pi r divided by 2. You should get 10 pi. Actually, if I'm ever out in the East Bay and I stop, this is really great Chicago style pizzeria in Berkeley. I'll bring you guys if I ever get a chance to stop by there. Zachary's. It's so good. I think it's better than any true Chicago style pizzeria. It's really good. It's been around for like 40, 50 years. Oh, trust me, it's good. Everywhere, yeah, yeah.
CIO. It's in Berkeley.
Okay.
My dad.
Which one is this? Okay. Not heard that one. Okay. And also this is in inches, by the way. Okay. All right, let's keep moving, guys. Now, next up, we're gonna keep breaking this down. All right. So now we understand fractions. What's happening? We did half a pizza. Now I told you that the slice had a 45-degree angle. Okay, fine. So let's say a different pizza. Okay, guys, that's my fault. I got us off track. Oh yeah, many times.
Oh, like compared to.
Oh, I think Zach, yeah, this is way better. Yeah. My wife disagrees because she lives in Chicago, but I think I'm right. So yeah, I think I'm right. So anyhow,
Have you ever been
to where?
to
No, not that. No. Oh, the bean. Oh, this is a bee. Sorry. Oh, of course. Oh yeah. Oh yeah. It's this giant metallic sculpture. It's concave. Yeah. Yeah. Yeah.
You know,
All right. Okay, guys, let's keep moving. All right. So now you got a 45-degree slice. Now here's what I did. Before I drew the red line, I made 4 slices of pizza, right? If I do 4 slices of pizza, what's the measure of each angle? No, 4 slices. What's the measure of this angle right here? 90, right? Because you're doing 360 divided by 4, right? If I want 45 degrees, I have to then do these extra slices here. So now I got myself 8 slices. How do I get 8 slices? Because I'm doing 360 over 45. And that 8 looks terrible. Looks like a 5. Let's make it a little better. So you have 8 slices of pizza. So what's the exact area she ate? Well, I'm just going to do 1/8. 1/8 of pi r squared. Now, if your diameter is 16, what's your r? Yeah. So pi times 8 squared, which should be, sure, fine.
yeah.
Because you guys are OCD, I don't know. But both. Both. Anyway, 1/8. Yes, I am a little OCD. I will admit that.
Because
Yeah,
over 6.
correct. We're gonna get there in a moment. Yes, yes. No, 45 degrees. I determined as 1/8 because I had 360 divided by 45. Right. So she ate 8 pi, guys. 8 pi square inches. And what's the exact length of the crust? Well, that's just 1/8 of the circumference, right? Which is 16 pi.
Because the circumference is 2.
Pi d or 2 pi r. Pi d, yeah. Circumference is pi d, and that's 2 pi inches.
Because six, isn't it 8?
No, she had 1/8, right?
Oh, because it's 1/8 times.
Right, right. So first of all, do you guys see why I'm doing 1/8? Because you had 8 slices, you're only eating one slice, right? So you see that connect, because that's kind of a big deal. We have to understand that. And then also, area you guys know, diameter 16, radius is 8, so area 64 pi, circumference 16 pi, and you're just doing 1/8 of both those quantities. Here's where it gets a little dicey. What if like you just cut this up like just kind of random, like I'm just gonna cut it this way, right? And 72 degrees. A little hard to do 365 by 72. So what we're gonna do, this is actually kind of the most important thing we talked about today, and kind of a big deal moving forward because I don't want you guys memorizing formulas. I want you guys to understand why this works. The fraction of the slice, sorry, to determine the fraction, the slice. Sorry, I'm just really struggling with my words here. To determine the fraction for the slice, divide the central angle by 360 degrees. Yeah, that's what I want to say. Perfect. So that's what you gotta do. So yes, you can do 360 or 72, but what if it was like 68 degrees or 44 degrees? Like those are just really weird numbers, right? So I would recommend to do that. Now, one thing that you guys probably don't know in your graphic calculator, and you'll really appreciate this. If I go to TI-84, and let me minimize this, and it's all these stupid ads. So if you use 72 or 360, let me clear screen for a moment. So if I do 72 over 360, right? It's going to give you some decimal. Here's what you could do. If you hit math, and the first option says frac, and hit enter, it will reduce that fraction for you. So it's math option 1. I don't know what's going on here. What? What? Okay, this is so dumb. Well, let me back. I I don't even search Minecraft. I don't even know why it's doing that. I don't even like go to McDonald's. Like, okay, what's going on here? These ads are funny. Anyhow, you can reduce fractions that way. That's all I'm gonna show you. Let's see.
Mr. E, should I leave it on your desk? Mr. E, that was hard.
All right. Anyhow, yeah. So anyway, you can reduce fractions that way. So in this case, 72 or 360 is 1/5. So now we know what to do. You're eating 1/5 of the pizza, right? If you're eating 1/5 of the pizza, that's gonna be 1/5, and it's the same radius, so it's fine. Pi times 8 squared. So 64 pi over 5. And you can leave it like that. That's totally fine. Because that is exact, because you can't reduce that anymore. So it'd be 64 pi over 5. Or for the crust, that'd be a 1/5 times 16 pi. So it'd be 16 pi over 5. So hopefully you guys are okay with that.
Circumference is 5D.
Or 2 pi r. They're the same thing. So remember r's diameter twice r. Okay. Let's keep on moving. I don't know. It is very judgmental. They're like analyzing your diet. Okay. So now that you guys are aware of this, try D&E right? Try D&E on your own or with your table group, and we'll check it in a couple minutes.
Are we?
Yeah, D&E. Yeah, yep. And exact answers, by the way. We want exact answers.
Yeah, I can't read when you're reading out loud.
Are you a Raiders fan?
Yeah.
No. Well, I feel sorry for you. You're a Raiders fan. You totally get Fernando, but he's gonna like suck. You have no one. He has no one to throw to. He's like no coach. Seriously, like,
Thanks for him.
no. You know what the really no. You know what the real issue with the Raiders is their ownership. Until, well, he inherited from his dad. So like until he sells the team or he dies and someone else takes it over. What was that? No, the Raiders have one of the best markets. They're in Las Vegas. They have like one of the best. Like, you have so many people are going to come visit your stadium. Like, no, they have a great opportunity, and they just have a dumb owner. Like, that's same with the Cowboys. Sorry for a Cowboys fan. I think it's great. He's old, but we do need a red zone target. So, yeah.
No, unless, because we're trying to get more. We're trying to get more. Offensive line.
The blockers. I will say the Raiders did make a good trade though. That was a very good trade because they got a lot of good. They got 2 draft picks out of it.
They're so bad. No.
Ever since they lost the Super Bowl in 2002, they've been crap. Except one year they went to the playoffs with Derek Carr. Yeah, and they had like Randy Moss like for like the worst part of his career, and then he blows up for New England. Like, this is the be it one of the Niners. Niners are much better.
Wait,
Was that?
is needed?
Yeah, it is. Yeah.
My dad was. My dad likes the Browns. Yeah.
Oh, I feel really bad for your dad now. If you're from Cleveland, you have to. I mean, that's your team, but
Like the whole basement is just like brown stuff.
a team that's never been to, it's been around forever and never been to a Super Bowl.
The guy they can go. Guys, I would rather make that happen.
I don't know who their ownership group is, but that Deshaun Watson deal like set them back like 5-6 years. Yeah, like that's just
But like, they just need to like, they need to stop and then get some first round picks and just like restart. 'Cause they are not.
historically they okay. Garrett is that's the only good. Miles Garrett's the best move they ever made. That's probably it. That's it.
I really like.
Miles Garrett's great. Nick Chubb was great too. Yeah. All right, let's talk about this. This is great football talk, but we've talked football all day. All right, anyhow, here's what you want to do. So you want to take the central angle and divide by 360. The reason why you want to do that is because that's the fraction of the circle you're dealing with. So if you have 30 degrees, right, for that arc, what's happening, I kind of hit it with the box there. And let me do a different color so it stands out. But what's happening is that you're drawing an arc like this. And if that's 30 degrees, your task is to find the fraction, right? So this right here is a fraction of the circle that we want. That's the fraction circle we want. And of course, you're dealing with circumference because arc is a portion of the circumference, right? So you got to figure out what portion. It's all about proportions. All it ever is. Because if you think about it, 30 over 360 equals the arc over the circumference. So the arc over the circumference equals the central angle over 360. Sorry, that's really hard to read. But the arc over the circumference, right, that fraction is the same fraction as the central angle over 360. They're all proportional. So if you use proportional analysis, you'll never ever miss these problems. Again, like I do talk about ST often, but like I do work with students on ST stuff, and they say, oh, I forgot the formula. I don't have this. Like, you don't need the formula. All you need to realize is a fraction. The fraction is 1/12. Great. Apply that fraction to the circumference. That's all you ever need to do. So it's just a slight extension to what we've been doing already. Likewise here, you have a sector. A sector is a section, right? That's a section of a circle. So it's not just the arc, but it's also the inside as well. So it's like the whole piece of pie or the slice of pie, right? Section of a circle. So 20 over 360, great. That's 1/18th. Multiply to the area, and that's what you get. That should be 50 pi over 9. Okay. Ooh, oh. It's like really loud. Okay. Okay. Any questions on D&E? No? All right. So now, just a quick summary. I just want to do a page of the next sentence, and we'll stop. You guys can do delta math. So the area of a circle, if it's 1, then the area is pi units. Pi is 3.1415926, a bunch of random digits. Pi r squared, we know, is the form for area. Circumference 2 pi r. You can also use pi d. All circles are similar to each other. We know that. Arc and sectors we talked about as well. Arc is a portion of the circumference. Sector is a portion of the circle. So, just it seems intuitive, arc and sector, right? So let's just briefly talk about this page here. We should be done in a few minutes. So you guys can start, and then you guys can actually tell me what you want for delta math, because I made delta math too long. So you guys can tell me what you want it for. Yes, exactly. I'm going to build a delta math with you guys. So if you think it's a little too much, we can reduce it, right? So anyhow, Earth's orbit around the sun is slightly elliptical. We'll assume it's a circle. So it can be approximated by a circle with a radius of 93 million miles. Okay. So obviously we orbit around the sun, right? How far does Earth travel in one orbit around the sun? So basically, what is the circumference? Well, circumference is going to be 93 million. So 2 pi times 93 million. So it'd be 186 million pi. And that's in miles? Yeah. So that's crazy, right? Or if I approximate it, 186, 123, 123 pi, you get 584, 336, 233.6 miles. So it's nearly 500 million miles away. Oh, sorry, the orbit. The orbit's 500 million miles. So, but this is where it gets more interesting, though. Because fine, we know we're far from the sun, right? We're never going to travel to the sun. That's crazy. Plus, you burn up if you get close to the sun, right? But that's orbit, right? The orbit is that. Now, here's the question. This is where it gets to be a little more interesting. How fast is Earth traveling in its orbit? Okay. Now, if we think about it, so obviously we spin as well, but when we orbit around the sun, how long do you think it takes to complete one orbit around the sun? 5 days. There we go. Yeah. We spin, but also the Earth is spinning too. Now, obviously, we spin in 24 hours. We know that. Yeah, yeah, yeah.
Okay.
But we don't feel it because that's the whole physics thing. So anyway, one orbit. Okay, guys, Zoe, guys, let's focus. It's 365 days, right? Unless it's a leap year. So it's going to be 584, 336,233.6 over 365 days. However, we want miles per hour, not miles per day. Now, for those who are sophomores and you've taken chemistry, you probably know what I'm talking about. You guys done like mole conversion, grams conversion. It's kind of the same thing. Yeah, freshmen, you'll do it next year. Um, so how many hours in a day? So you're gonna set up like this. So this is called dimensional analysis. What you're doing is I'm multiplying the first fraction by its conversion. Why am I putting days up top and hours on the bottom? You want yes, good. So there you go. And I want hours on the bottom anyway. Yeah, good.
Yeah, why are you?
Because I want the days to cancel. Because I want miles per hour.
I would have done hour because like per overhaul and the days tend to feel.
Yeah, I mean you could just convert 365 to hours right away, multiply by 24. And then just divide afterwards. But
We're supposed to be able to do all this like for the test stuff, like this part.
I don't even know what we're testing on. I haven't thought that far ahead. 233.6. Hold on, let's work this out. Okay, what do you get, Ollie? Oh, but you have to divide by 365 also. Okay, so it's actually this fast, guys. This is crazy. So the Earth is moving at more than 66,000 miles. Yeah, it's been this way since God created the Earth,
Wait.
or whatever you believe, big spirituality. So, yeah.
Oh, never mind. When you go to Earth, how do you get back into the traveling?
Well, that's inertia. That's another. That's like a separate thing. So, all right, last one here, and then we'll stop here for today. All right. So, windshield wipers. Obviously, we haven't had rain in a while, but windshield wipers work in this fashion. And usually there's a little gap. It doesn't clean, right? So the question is, find the area that's actually wiped during the swing, each swing of the wipers, right? So here's what you're going to do. You have two sectors, right? We have sector 1, and we have sector 2. I'll call this sector 1. I'll call this whole thing sector 2. Okay. And that's kind of hard to tell. That's really not obvious. We'll call that sector 1, the little white portion, and we'll call the whole thing sector 2. The shaded region is going to be sector 2 minus sector 1. So what I'm trying to do is I'm trying to find the area of the whole minus the little, big minus little. Yeah, Peter, go ahead.
What is the radius? 20?
Well, for sector 1, what's the radius? 5. So, and what's the central angle? So it's 1/3. So 120 over 360. And you want to find the area, so times pi 5 squared.
Was 15 with the 5 or not counting 5?
No, it's 15, not counting 5. So it's 25 pi over 3. Here, what's the radius of the big sector? 20, right? Yeah, good. So it'll be 400 pi over 3. This is where geometry can get a little complicated because we're going to start doing a lot of funny shapes. And that's why I don't want to do all this today. We're going to do the rest of this on Thursday. So you get 375 pi over 3. And I think that does reduce. Yeah, it's 125 pi. And that's in square inches. So what I did was I found the area of the little white portion, the area of the whole thing, subtracted it to, and that gets you the shaded part, what's left over. You can't find the shaded part directly. You actually have to find the area of both and subtract. That's how you have to do it. So that's just give you a little taste of some of the more complex problems we'll do on Thursday. Yeah, you can see like we're doing. Actually, we should bake cookies too on Thursday. Maybe we could do that. Why not? Let's just bake it up. Yeah. And we could run around the track too afterwards.
And
Yeah. Anyhow. But yeah, that's the plan. I'll send you guys an email and also send an invite if the hearth is open. I have to assume it is open. I mean, I had to have to book it first. I just sent an invite, so actually find out if they did book it for us. So now let's do Delta Math, but give me 1 sec. Do you want to see if they booked the hearth for us?
like when you were little, and then I feel like this is the best. What? Amazing. So when I'm playing with the card, I know it's going for it. It's not like finding all of these photos.
I also put the link in the school agenda homework number 21. And we're all done.